Breaking news from SpaceX. They've just accomplished something extraordinary. For the first time ever, parts of a super heavy booster have been recovered from the ocean floor, marking a historic milestone in rocket reusability. The recovered segments of Booster 11, which performed the first ever successful water landing, are now providing invaluable data to SpaceX engineers. But that's not all. Starbase is transforming at an unprecedented pace. The second Mechazilla tower stands proud against the Texas sky, now joined by segments of a revolutionary new launch mount design. Gone are the days of the circular launch stool. SpaceX is innovating yet again with what appears to be a completely redesigned square configuration. Meanwhile, Crew Dragon continues pushing boundaries with a groundbreaking announcement. The capsule now has propulsive landing capabilities as an emergency backup. It's a feature that brings us one step closer to SpaceX's original vision for the spacecraft. In other developments, Ship 30 is sporting some intriguing heat shield modifications. China has unveiled their new lunar spacesuit, and fascinating changes are happening at the launch site that you won't want to miss. Welcome to Elon Musk 24 Hours. Let's dive right in. The landscape at Starbase tells a story of rapid evolution. Standing at the heart of this transformation is the new Mechazilla tower, a testament to SpaceX's relentless innovation. Just 12 months ago, this area was barren Texas coastline. Today, it's home to what might be the most advanced rocket-catching system ever designed. But the real story lies in what's happening at ground level. The new launch mount segments recently spotted at the site reveal a dramatic shift in SpaceX's thinking. Gone is the circular design that defined earlier launches. In its place, a square configuration is taking shape. A change that engineers believe could revolutionize how Starship handles the intense forces of liftoff. The first two segments arrived under cover of dawn, their geometric profiles casting long shadows across the launch complex. Their design speaks volumes about what SpaceX has learned from previous launches. The square configuration isn't just an aesthetic choice, it's a complete rethinking of load distribution and structural integrity. In a remarkable turn of events, the HOS Ridgewind vessel has returned from what might be the most ambitious salvage operation in SpaceX's history. Booster 11, which made history with its controlled water landing, is gradually revealing its secrets from the depths of the Gulf of Mexico. The recovered sections tell a compelling story of survival. Cut precisely in half for transport, the booster segments show surprisingly minimal damage from their ocean ordeal. Engineers hovering over the recovered hardware are particularly interested in the engine section. Every scorch mark and stress pattern could hold vital clues for improving future designs. But SpaceX isn't done fishing. The HOS Ridgewind has already embarked on another recovery mission. Maritime tracking shows the vessel returning to the exact coordinates where Booster 11 made its historic splashdown. Sources suggest they're particularly keen to recover the engine that malfunctioned during landing. Its analysis could prevent similar issues in future missions. While recovery operations continue at sea, the evolution of Starship continues on land. Ship 30 stands proudly on the launch mount, but keen observers have noticed something peculiar: strategic gaps in its thermal protection system. This isn't an oversight, it's deliberate engineering at work. The missing tiles reveal an intricate layer of experimental ablative materials underneath. One section shows a distinctive blue stripe, possibly indicating a new type of thermal protection never before seen on a spacecraft. This matches SpaceX's pattern of continuous iteration, where each vehicle serves as a test bed for improvements. Ship 31, fresh from its successful static fire campaign, is receiving these same advanced modifications. Inside the high bay, teams are meticulously installing what could be the most sophisticated heat shield yet developed for Starship. The precision of their work is crucial. Each tile and ablative layer must perform perfectly during the intense heat of atmospheric re-entry. The Star Factory is pushing boundaries of its own. Ship 34's construction reveals how SpaceX is revolutionizing spacecraft manufacturing. The payload section, now temporarily housed in the factory, demonstrates remarkable headroom for future modifications. This extra space could accommodate even larger segments, suggesting SpaceX is thinking well beyond current designs. The high bay's role is evolving too. What was once the primary assembly point for Starship is transforming into something new. Whispers among workers suggest plans for a megabay, a facility that could fundamentally change how these massive vehicles are assembled. The recent Crew 9 launch marked a pivotal moment in spacecraft safety systems. What started as a routine mission to the International Space Station has unveiled a groundbreaking capability: propulsive landing as an emergency backup. This revelation from NASA's Commercial Crew Program Manager Steve Stitch represents more than just a new feature. It's the resurrection of SpaceX's original vision for Crew Dragon. The Super Draco thrusters, primarily designed for launch escape scenarios, can now serve as a last resort landing system. This capability will be tested during the upcoming returns of both Crew 8 and Crew 9. Should all parachutes fail, an extremely unlikely scenario, the capsule can fire its thrusters to ensure a safe water landing. It's a level of redundancy unprecedented in crewed spaceflight. While SpaceX pushes forward with these innovations, international competition is intensifying. China's recent unveiling of their Lunar spacesuit demonstrates their serious intentions for lunar exploration. The suit's design, while sharing DNA with their Tiangong space station suits, includes crucial modifications for surface operations. The Chinese suit's leg bearings allow for impressive mobility, though it lacks the advanced waist bearing seen in NASA's XEMU suit. This technical detail highlights the different approaches to solving the same fundamental challenge, enabling astronauts to work effectively on the lunar surface. These developments are playing out against a challenging financial backdrop. NASA's new budget authorization of $25.2 billion, while substantial, falls short of their request by $200 million. Accounting for inflation, this represents an effective budget cut at a crucial time. The impact on NASA's lunar ambitions could be significant. Their 2026 target for returning humans to the moon faces mounting pressure, especially as China maintains its steady progress toward a 2030 lunar landing. The 4-year gap between American and Chinese lunar ambitions might be shrinking. The timeline shifts in the Artemis program illustrate these challenges. What began as a 2019 to 2021 window for Artemis 2 has steadily moved right, now targeting September 2025. Even this date faces scrutiny, with Starship's development and regulatory hurdles adding complexity to the lunar landing equation. This evolving timeline plays against the backdrop of China's methodical progress. While their 2030 target might seem distant, their track record of meeting aerospace deadlines demands attention. The space race is entering a new, more complex phase, where technical capability must balance against financial and regulatory realities. As we wrap up today's journey through the latest developments in space exploration, one thing becomes crystal clear. The race back to the moon is intensifying in ways we never expected. SpaceX's innovative recovery of Booster 11 and their groundbreaking launch Mount redesign show how rapidly space technology is evolving. Meanwhile, Crew Dragon's new propulsive landing capability adds another layer of safety to human spaceflight, proving that innovation never stops. The contrast between NASA's budget constraints and China's steady progress toward their lunar goals presents a fascinating dynamic. While the US still leads this new space race, the gap may be narrowing faster than we anticipated. These developments remind us that space exploration isn't just about technology, it's about commitment, resources, and vision. If you're as fascinated by these developments as we are, make sure to hit that subscribe button and join our growing community at Elon Musk 24 Hours. Drop your thoughts about SpaceX's new launch mount design in the comments below. We'd love to hear your theories. Don't forget to share this video with fellow space enthusiasts who need to stay informed about these crucial developments. For more daily updates on everything happening in the world of SpaceX and space exploration, hit that notification bell. Together, we're witnessing history in the making, one launch at a time. See you in our next update. Tesla has just shattered what we thought was possible in electric vehicle technology. In a move that's leaving industry experts speechless, they've achieved something extraordinary with the upcoming Model 2's powertrain. A staggering 75% reduction in silicon carbide usage, while delivering performance that rivals their premium models. This breakthrough takes us back to 2017, when Tesla first stunned the automotive world by becoming the pioneer of silicon carbide drive inverters in the Model 3. But what they've accomplished now with the Model 2 goes far beyond that initial innovation. They've not only preserved that groundbreaking technology, but transformed it into something far more powerful and accessible. The implications are massive. We're looking at a 40% reduction in production costs, yet the performance numbers are nothing short of remarkable. At a target price of $30,000 before incentives, this isn't just another electric vehicle. It's the beginning of a new era where high-performance EVs become accessible to everyday drivers. The secret lies in Tesla's relentless pursuit of innovation. Their engineering team has completely reimagined how electric powertrains can work, proving once again why they're leading the electric revolution. This isn't about cutting corners. It's about cutting-edge technology that makes premium performance available to everyone. Welcome to Elon Musk's 24 Hours, where we bring you the most exciting developments in Tesla's journey to transform transportation. Let's dive right in. The journey to Tesla's latest breakthrough began in a rather unexpected way. During a late-night engineering session at Tesla's powertrain development facility, the team made a discovery that would change everything. While examining the Model 3's silicon carbide inverter under extreme testing conditions, they noticed something remarkable: the potential to achieve the same power output with significantly fewer components. Inside Tesla's revolutionary powertrain. The heart of this innovation lies in what Tesla engineers call intelligent power distribution. They've completely reimagined how electric current flows through the vehicle's nervous system. The traditional setup in the Model 3 used 48 silicon carbide MOSFETs. Think of them as the gatekeepers of power in an electric vehicle. Each one carefully controlled the flow of electricity from the battery to the motors. But Tesla's engineering team, led by their top power electronics specialists, questioned this conventional wisdom. Through thousands of hours of simulation and real-world testing, they discovered that by redesigning the entire power delivery system, they could achieve the same results with just 12 MOSFETs. This wasn't just a simple reduction. It required a fundamental rethinking of how power electronics work in electric vehicles. The numbers tell an impressive story. The new system delivers 211 kilowatts of power, matching the Model 3's performance, while achieving an unprecedented 94% efficiency, up from the previous 92%. In real-world terms, this translates to a 0 to 60 time of just 3.9 seconds, shaving off 0.6 seconds from earlier designs and extending the range to 270 miles. Breaking down the innovation. Tesla's engineers didn't stop at just reducing components. They completely redesigned the MOSFETs themselves. The new devices feature a larger die size and double the current rating, jumping from 50 amperes to an impressive 100 amperes. This means each MOSFET can handle twice the power flow of its predecessor, enabling fewer components to do more work.